Properties of definite integrals. So this is the last and final video in integration. So here we will be learning what are the different properties that we can use in definite integrals to solve questions. In the previous session, I have drawn a graph of f of x, which is sin x, and I have told you the areas are symmetrical to each other, right? Now I'm just doing a little modification over there and drawing a graph which is again 0 to pi sin x only. I'm drawing a y is equal to sin x over here. So I can see this is pi by 2. The midpoint over here is pi by 2. Yes. Now, if I just draw a vertical line like this, and if I shade this area from 0 to pi by 2. Now, this area, that is, if I take the total area from 0 to pi f of x dx, that I will be getting it as 0 to pi sin x dx. Now, this whole area can be split up into two parts. If I take a point which is in middle of 0 and pi, which is pi by 2, yes, surely I can do, because they look symmetric. If I draw this graph, I can see that it is symmetric to each other. That is, this part over here and this part over here are symmetrical to each other. Now, if I take 0 to pi by 2, if I only take 0 to pi by 2 sin x dx, I will be getting what? Integral of 0 to pi by 2 sin x dx will be minus cos x, and from 0 to pi by 2 means it will be minus of cos pi by 2 minus cos 0, which will be equal to 1 unit. Now, in the previous case, that is 0 to pi sin x dx, I will be getting it as minus cos x. From 0 to pi, that will be 2 units. So you can see that this 0 to pi by 2 integral sin x dx area is actually what? Giving the half of the area that we got from 0 to pi. So that means I have a small property from this equation or from this integral. That is, if I take 0 to 2a f of x, and I can also write this as 2 times 0 to a. So what happens to the limit? From 0 to 2a, the limit now changes to 0 to a. That is, now it is doubled, 2 times 0 to a f of x dx, only under the condition when f of 2a minus x is equal to f of x. If this condition is satisfied, we can use the direct property, that is integral 0 to 2a f of x dx can be written as 2 into integral 0 to a f of x dx. Understood? So it's a quite useful formula. Now, condition has to be satisfied, that is f of 2a minus x should be equal to f of x. Now just look at the condition over here, that is y is equal to sin x. So 2a means it is pi. So what is f of 2a? F of 2a minus x, that is f of pi minus x, will be sin pi minus x, which is same as sin x, or it is f of x. So here you can say it is f of 2a minus x or f of pi minus x is definitely equal to f of x. So you can say this is equal, and you can use this property, which is 0 to 2a f of x dx is equal to integral 2 into integral 0 to a f of x dx, a very important property. So like this, there are many other properties which we can use in definite integrals. And what are they? So let's look at each of the properties. The first property we have here is integral a to b f of x dx can be written as, if I change integral a to b, if I change the variable from x, if I change to t, I can also write it as f of t dt. That will be the same. The answer will be the same, exact same answer you will be getting. So I'm not changing the limit here, I'm only changing the variable, which is x, which now changed to what? T. That is the first property. Second property is integral a to b f of x dx. That is, if I take the area from a to b, that area will be equal to the negative of area from b to a. A normal formula that we can understand without even drawing a graph or anything, because if I change the interval from b to a, the area should be negative, right? So it should be this way, that is integral a to b f of x dx should be equal to minus of what? B to a f of x dx. The third property goes like this: integral a to b f of x dx can be written as, in place of in between a and b, if I have a third point c. So now that I can write, that is in between a and b, I have a point which is c. So if there is a point like that, then I can write it as a to c f of x dx plus c to b f of x dx. So I can split that and write it as two separate integrals. If there is a fourth one d, then I can again split that from a to c, c to d, and d to b. So these are the different properties, the first three properties. Now moving on to the fourth one, integral 0 to 2a f of x dx, that the property that we just written can be written as 2 into integral 0 to a f of x dx if f of 2a minus x is equal to f of x. That's a property we have discussed. Now coming on to the fifth property, integral 0 to a f of x dx can also be written as integral 0 to a f of a minus x dx. Very important property. The sixth one, a similar property of the same previous one. If I write integral a to b f of x dx, I can also write it as integral a to b f of a plus b minus x dx. So this is a very important property. So if I have a limit from a to b f of x dx, then I can add these two limits and subtract x. That is, integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So that is a sixth property, and this fifth one is actually a result of the sixth property. Yes, because 0 to a f of x dx can be written as 0 plus a. What is 0 plus a? A minus x. So it can also be written as 0 to a f of a minus x dx also. That is the sixth one. Seventh property, integral minus a to a f of x dx can be written as two ways. That is, it can be written as 2 into integral 0 to a f of x dx, or it can be also equal to 0. So there are two ways in which this can happen. Now, how can this happen and what is this property saying? Now, this property is used when the function is either even or odd function. So if the function is either even or odd, these two results can come up. Now, the first result comes up when f of x is even. F of x is even. And the second result 0 comes when f of x is odd. So these are the this is the last property where we have to learn, that is minus a to a f of x dx can be written either 2 into 0 to a f of x dx or it is 0 when it is an odd function. Now how to check whether the function is odd or even? It's very important, right? So to check whether the function is odd or even, you just need to see f of minus x. If f of minus x is equal to minus fx, then it is an odd function. If f of x minus x is equal to minus of f of x, it is an odd function. And f of minus x is equal to f of x, then it is simply an even function. So very important. So to identify whether the function is even or odd, you have to use this rule and check whether it is even or odd. If it is even, then this is the way, that is 2 into integral 0 to a f of x dx. And if it is odd, that is f of minus x is equal to minus of f of x, then it is directly written as 0. Understood? So these are the different properties that we have to use in definite integrals. Now let's do one question to understand how we can use these properties in definite integrals. So we have a question over here, that is integral minus 1 to 3 mod of x cube minus x dx. Mod of x cube minus x dx. How can we solve this? There is actually a mode function. Modular functions integral we have not studied till now, right? So how can we find out what is the direct value of this minus 1 to 3 mod x cube minus x dx? So to do that, what is this mod x cube minus x? And I write x cube minus x and say x cube minus x can be written as x into x square minus 1, or it can also be written as x into x plus 1 into x minus 1. Yes. So if I equate this with 0, I'm just equating this with 0, I will be getting x is equal to 0, x is equal to minus 1 and 1. So there are three different values. So if I draw a number line, what is it? Lowest value minus 1, then I have 0, then I have 1. So I can see that this x cube minus x, so I'm just leaving out the modulus for the time being, I'm just taking x cube minus x and equating it to 0, I will be getting three different values for x, minus 1, 0 and 1. So I have 3 or 4 intervals, right? I have one interval over here, another one over here, another one, another one. So I have 4 intervals over here. Now, what happens when I take these intervals? That is, I can write it as minus 1 to 0, yes, because our question starts from minus 1 to 3. So minus 1 to 0 is one interval, 0 to 1 is another interval, and 1 to infinity, no. I have only till 3, so I take it as 3. So there are 3 intervals. Now, what is the sign or what is the magnitude in these cases? Whether it is positive or negative, we have to check. So if I take x into x plus 1 into x minus 1, and the interval, first interval minus 1 to 0, second one 0 to 1, and the third one is 1 to 3. what is the sign of each in interval. So minus 1 to 0 means I can put a small value minus 0.5. So if I put minus 0.5, this will be negative, this will be positive, this will be negative. So I have total a positive value if I put a value in between minus 1 and 0. Now 0 and 1, if I put a small value, I will be getting positive, positive and negative. So that means here it is negative. This x cube minus x will be negative. 1 to 3, if I put a value, I will be getting positive, positive, positive. So that is positive. So this whole minus 1 to 3 integral can be split up into 3. That is, it can be from minus 1 to 0, then 0 to 1, and from 1 to 3. So 3 intervals. So here what I have done is I have taken the property integral a to b f of x dx and used this as a to c f of x dx plus c to b f of x dx. So using that I can find out the value here. So from minus 1 to 0, check for the sign. It is positive. So that means it is x cube minus x. The modulus sign is positive. So it is x cube minus x. From 0 to 1, it is negative. So it is not x cube minus x. It is x minus x cube. So plus x minus x cube. Then plus 1 to 3, it is again positive. So I can write it as x cube minus x. Now I just need to find the final answer. Putting all dx over here, I will be getting the integral as x raised to 4 by 4 from minus 1 to 0 minus x square by 2 from minus 1 to 0 plus x square by 2 from 0 to 1 minus x raised to 4 by 4 from 0 to 1 plus x raised to 4 by 4 from 1 to 3 minus x square by 2 from 1 to 3. So these are the different parts that we get after integrating. So putting all the final values, I will be getting 0 minus 1 by 4 minus 0 minus 1 by 2 plus 1 by 2 minus 0 minus 1 by 4 minus 0 plus 3. If I put 3 raised to 4 by 4, that is how much? 81 by 4 minus 1 by 4 plus 3 square by 2, that is 9 by 2 minus 1 by 2. So this is what I get. So minus 1 by 4 plus 1 by 2 plus 1 by 2 minus 1 by 4 plus 80 by 4, that is 20. 9 by 2 minus 1 by 2 is how much? Is 8 by 2 or plus 4. So I can write it as minus 1 by 4 and minus 1 by 4 is minus 1 by 2. 1 by 2 plus 1 by 2 is 1. 1 minus 1 by 2 plus 24. That is 24 plus 1 by 2. So it is nothing but 49 by 2. So this gives us the final answer for the question, that is minus 1 to 3 integral x cube minus x. The result is 49 by 2. So here I have used the property of definite integrals, which you have to see. That is, this is the property, that is integral a to b f of x dx is now written as splitted form, that is a to c plus c to d or c to b. If I'm splitting that into 4 parts, then a to b, b to c, c to d, and it goes on like that. So I have used a property over here and I have splitted that using that property, and only thing that we have to check here is for the modulus sign. For the modulus sign, it can be either positive or negative. So we have checked that also. So we have checked that over here. So that is how you use the properties of definite integrals here to solve a question. Now we will wind up the session with one more question. And the question here is integral pi by 6 to pi by 3 dx by 1 plus root tan x. Now, first of all, write this root tan x as 1 plus root sin x by root cos x, and if I take the LCM, I'll be getting over here in the numerator, I'll be getting it as root cos x dx by root sin x plus root cos x. So this is what I get. So what I'm going to do here is I'm just going to put this whole thing as I. So I'm just putting this integral as I over here. So pi by 6 to pi by 3 root cos x by root sin x plus root cos x dx is equal to I. Now what I do here is I'm going to use the property, that is a to b f of x dx can also be written as integral a to b f of a plus b minus x dx, right? Yes. So if I use that, I will be getting I is equal to pi by 6 to pi by 3. What is the sum of pi by 6 and pi by 3? It will be pi by 2. So can I write as f of pi by 6 plus pi by 3 minus x, or I can also write as what? F of pi by 2 minus x dx. So when I use that, I will be getting pi by 6 to pi by 3. F of pi by 2 minus x is root cos pi by 2 minus x by root sine pi by 2 minus x plus root cos pi by 2 minus x dx. So you will be getting, don't forget to put the I. So you will be getting it as pi by 6 to pi by 3 root cos pi by 2 minus x is root sine x, by here again root cos x in the denominator plus root sine x, because you know that it is sine pi by 2 minus x and cos pi by 2 minus x, so that should be there. Now I have I is equal to this one. In the first phase you got I is equal to root cos x by root sine x plus root cos x. Now I have root sine x by root cos x plus root sine x. So what I'm going to do here is I'm going to add these two, so that is I plus I is equal to pi by 6 to pi by 3. Both are having the same denominator, so I can write it as root sine x plus root cos x by root sine x plus root cos x dx. So it gets cancelled and you get it as pi by 6 to pi by 3 1 dx, or it is x from pi by 6 to pi by 3. So 2I is equal to pi by 3 minus pi by 6, which is nothing but pi by 6. So 2I is pi by 6. So what is I? From here I will be getting as pi by 12. So here also I got the final answer for the integral by using the property, that is integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. And that's a very important property in definite integrals that we have used here. Now one more last thing, that is if I have minus 1 to 1, integral minus 1 to 1 sine raised to 7x dx, sine raised to 7x dx, what will be the value of this minus 1 to 1 sine raised to 7 dx? So look here, you have sine raised to 7 dx as f of x. Now what is the f of minus x? If I put a minus x over here, it is sine raised to 7 minus x, which is minus sine raised to 7x. Is that is equal to minus of f of x? Yes. So here f of x is now f of minus x is equal to minus of f of x. So if that is the case, then minus a to a f of x dx is what? We have studied that property. It is equal to 0. So now it is an odd function. Minus 1 to 1 sine raised to 7x dx can be written equal to what? 0. So that is how you find out the value using a direct property that we learned in definite integrals. So these are the various uses of definite integrals in properties, using the properties, right? Because you get to solve the answers in a very faster way. You don't need to find the integral, you don't need to subtract, or you don't need to apply the limits. You directly can write the answer here as 0 just by saying the property. Use the property, mention the property in the answer, and you get the final answer. So that is all about integration. And in this complete chapter, we have covered around what is indefinite integration. Then we have studied the different methods of solving indefinite integrals, and then coming on to definite integrals, the methods of solving there, the properties, and also fundamental theorem of calculus also we have studied in this whole chapter. Now let's just have a quick recap of this session.
Manorama Horizon. Learning made simple.